Good day, students. So in this video, we are going to talk about interest. And because interest can be a little bit complex, this video might be longer than the typical 10 minutes. I'm going to try to keep it around 10 minutes, but just a little warning about the time limit. In your vocabulary, you should have already kind of gotten a brief definition about the difference between what's known as simple and compound interest. In that vocabulary sheet, we also talked about good versus bad interest. In this video, we're talking about good interest. This is interest that's earned on retirement accounts, savings accounts. Basically, this is just interest earned by like leaving your money in an account and not touching it. So this is a form of good interest. But the way that interest is calculated can be in a couple of different ways. So simple interest is when we calculate the interest on something just once, or if it is in an account over time, it's just interest based on the principal amount, the amount that you put in. So for example, if I put in something at $3,000 at a 6% interest rate, that means every year I'm going to earn 6% of 3,000 and it's going to be added into my account. Versus compound interest is when we earn interest even on our interest. So what that means is if I put in $3,000 into an account at a 6% interest rate and it's compounded interest, what that means is the first year I'm going to earn 6% on 3,000 and there's going to be an amount in the account. The next year I'm going to earn 6% on that new amount that's in the account instead of just the principal amount. So a lot of times compound interest is better because you earn more money that way because your interest is earning interest versus just your principal amount earning interest when we're talking about simple interest. How many times can I say interest in this video? Someone needs to do like a little tally count to see. Another thing that I'm going to use in this video that I am going to recommend that you use, and I'm sure your teachers are going to recommend that you use, is a calculator. What? Yes, a calculator, because especially compound interest, because it compounds over time, we actually have an exponent in our formula, and doing that by hand with a lot of decimals can be very complicated. So having a calculator, particularly a graphing calculator, is really great. I don't have a physical graphing calculator with me. Those are the ones that are kind of like large and rectangular, but there is actually an app that you can get on your phone. I have an iPhone, so if you have an Android or a different kind of phone, I'm sure you could probably get it in your app store as well, but it's called Calculator X. You can also get the graphing calculator Desmos on your phone as well too. You do use Desmos a lot in algebra, so it might be beneficial to get that one. So when we have our graphing calculator, this is what mine's going to kind of look like. If you had one of the physical calculators, your screen on that calculator or the buttons would kind of look like this. So this is the calculator I'm going to use in this video, but you can also use a physical calculator, a Google calculator. It's up to you. Okay. So here are our two formulas for simple and compound interest. So you'll notice the simple interest formula, we're taking P, which is our principal, times our rate, which is our interest rate, times time, which we said in the vocabulary video, we always measure in years. And so when we multiply these three together, we find out what the interest amount is. Now, that's not telling us how much is in our account. So if we want to find out how much is in our account, we're going to have to do some adjusting, but this is how we calculate simple interest. So let's do an example. So let's say we have a principal amount, someone invests $3,000 into the account. The interest rate is 6%, and the time is 36 months. Now, time always has to be measured in years. So 36 months is 3 years. And the way that I know that is I just divided 36 by 12 because there's 12 months in a year. 12 times 3 is 36, so 3 years. So if I plug in my values into my formula, so I put IN, but you can just put I. Interest is equivalent to 3,000 times our interest rate, but we want to put it as a decimal or a fraction. So I'm just going to put it as a decimal. So 6% is 0.06 times 3. And then to find our interest amount, I'm simply going to put those numbers in the calculator. So 3,000 times 0.06 times 3 equals $540. Sorry, it's a little hard to see on my screen, but this is equivalent to $540. So that is simply just the interest amount. This is how much interest this account earned after 3 years. If we want to know the balance in the account is going to be our principal amount plus the interest. So that's going to be $3,540 because it's our principal amount plus the amount of interest. Let's look at basically the same components, but let's see what the difference would be if we calculated the interest with compound interest. So I'll leave this one here so we can kind of reference it. So this is our formula, and you'll notice that instead of it being equivalent to the interest, this is equivalent to the letter A. A stands for account balance. So you can think about it as like the balance in someone's account. Okay. Having the letter B here might be a little bit easier, but sometimes B we use for geometry, right? We use for base. So having the letter A might be a little easier because it's account balance. So we have all the same things. $3,000 as a principal amount, 6% interest rate, 36 months, which is 3 years. So if we want to plug that into the compound interest formula, we have the account balance is going to be equal to 3,000 times, in parentheses, we have 1 plus our rate, or our interest rate. So 0.06, again, we have to put it to the decimal. And then this group is going to be taken to the power of time, which in this case is 3. So instead of making you do all of this by hand, I'm going to clear my calculator and we're going to type this into our calculator. So we have 3,000. And then I can simply just put a parentheses right next to it. Remember, anything next to parentheses means multiplication. 1 plus 0.06. Then I'm going to close parentheses. And then you'll notice there's an exponent button here. So I'm going to say to the, oh, that automatically took it to the power of 2. That's not what I wanted. So I'm going to go over and I'm going to hit delete. Delete. Oh man, it won't. Oh, there we go. Okay, it deleted. So if I want to take it to the power of 3, I'm going to use the little caret button right here. So I'm going to do to the power, and you'll notice it's really, really tiny on my screen, but it brings up the exponent box. I'm going to put 3. So it's 3,000 times 1 plus 0.06 to the power of 3. And if I hit enter, that is equivalent to $3,573. Oh no, an advertisement. Google Fiber. Okay, what it's equivalent to, I have it written down on my other paper here, is $3,573. And if I round it to the nearest hundredth, because we're talking about money, it should round to 5 cents. So this is the account balance, right? Like this is how much is in the account. So you'll notice already that compounded interest calculated more interest. So if we want to know the interest amount, we have to take our principal and subtract it. So $3,573.05 minus our principal amount of 3,000. So this is going to be equal to $573.05. So that's our interest amount. So you have to be really, really careful when you're calculating interest to see if it wants you to find the balance or the interest amount. And depending on the formula that you use, you might have to either add it to the total or subtract it because it depends on the type of interest that you're doing. Okay, so the next thing we're going to look at, and for the sake of time, I'm not going to type it into the calculator. The advertisement for Google Fiber did finally go away off my phone, but for the sake of time, for the next one, I'm just going to kind of tell you what the calculations are to make it a little easier. So if after you do these 2 examples, if you want to draw another line here to kind of make 4 quadrants, you can, but you don't have to do that. You can just keep it in the same column. So we have 2 more problems, but you'll notice in both cases, instead of calculating for either the interest or the balance, we're calculating the principal amount. So we are trying to figure out what is the principal in each case when they tell us what the interest or the account balance is. So basically what we're going to do here is we're going to plug in the values we have to the equations and then solve the equations, just like if we were like solving for X, but in this case, we're solving for the principal. So let's look at, excuse me. Let's look at the simple interest problem. So it tells us the simple interest is $675. The interest rate is 3% and the time is 6 years. And we're trying to figure out the principal. So if I plug that into the equation, I equals principal times rate times time, I know my interest is $675, so I'm going to plug it in there. I don't know what my principal is, so I'm going to leave that variable P. R is equivalent to 3% or 0.03 if I put it as a decimal. And then the time is 6 years, so I don't have to convert that. It's already in years. So this is my formula. So the first step is I'm probably going to simplify what's going on over here. So I have $675 is equivalent to P times 0.03 times 6. Well, 0.03 times 6 is going to be 0.18 or 1800ths. Again, you could use your calculator to do that. For the sake of time, I'm not. And then if I want to solve for P, well, if P times that amount is equal to 675, I could divide both sides of my equation by 0.18 and figure out what is the value of the principal. So 675 divided by 0.18 is equivalent to $3,750. I believe it equals that exactly. If it didn't, I would round it to the nearest hundredth. So the principal amount that they invested into the account was $3,750. This is the interest that was earned over time after so many years. Now, if we want to do a similar problem where we find the principal, but we're using the compound interest formula, it's going to look a little different. This one's a little complicated. And honestly, this is the biggest reason why I use a calculator is because of the compound interest formula with the exponents. So if my formula, which is equivalent to the balance the balance equals the principal times 1 plus the interest rate to the power of time, I'm going to plug in what I have. So the balance is equal to $2,500. The principal rate, I do not know. The number 1 is going to stay the same. My interest rate is 2% or 0.02. And then to the power of t, time is going to be 4. So if I'm trying to figure out the principal amount, I am going to figure out what is all of that equivalent to. So I just can plug it into my calculator. So basically what I'm doing is I'm taking, oh man, another ad popped up. Maybe this isn't a good app. I lied to you guys. Maybe Desmos is the better app. I got this one because I liked how the calculator took up the whole screen, and Desmos, part of the calculator is like graphing. So there's like a graph. Anyways, that's besides the point. So basically, if I take all of this to the power of 4, it's going to be equivalent to, it has a lot of decimals to it. So I'm just going to kind of put a ... but it's 1.08, and then it has a couple other decimals after it. For the sake of this, don't round it until the very end. So when you're doing it in your calculator, leave all of the decimals there. So that way you don't, you get it as specific as possible. I'm not writing all of them down because I don't know if I have enough space on the page, but leave them there on your calculator. And then if I want to find the principal amount, I'm going to take my value in my account and divide it by that long decimal, because t times that amount is equal to 2,500. So the opposite is to use the division property of equality. So if I do not round and I divide 2,500 by the long decimal in my calculator, I get, if I round it to the nearest hundredth, that final answer, I get $2,309 and about 61 cents if I round the decimal to the nearest hundredth. So this is the amount that someone invested to earn this amount of interest. So their total account balance is 2,500, but this is what they put in to earn that amount. So you'll notice, like, that's from what they invested to what they have now in their account. That's not that much, but the interest rate's super low. So if the interest rate was much higher, then this value would probably be much higher as well too. So again, interest is a very complicated concept, mainly because it's taking what we know about solving equations, but it has exponents and decimals and formulas and things like that. So you might want to watch this video maybe another round before you start your work. But I know because my calculator situation was a little chaotic. So I highly recommend you have a reliable calculator. Maybe don't use, I mean, the Calculator X app is pretty good. You just have to be aware that it's going to pop up with some ads every now and then because it is a free app. Desmos might be a better option. Or if your teacher has a legit graphing calculator, that's probably the best option that you can have to calculate. So To practice, I'm going to give you two practice questions, one simple and one compound interest. So here they are. I've given you all of the information in terms of the principal, the rate, and the time. And then I want you to answer the following. So what's the total investment on number one, and what is the interest earned? And don't forget, depending on if it's simple or compound interest, you may have to take the interest amount and add it or subtract it, depending on what kind of interest it is. So make sure you go back and refer to especially our first two examples as you're solving these problems. Sorry for the length of this video. Sorry for the little bit of chaos that came with the calculator. But if you have any questions, please make sure to reach out to your teacher. Watch this video again. I will also try to link some other videos that show you how to calculate interest as well, so you can see some other examples. And I hope you guys have a great day wherever you are. Be smart with your money. Bye.